We're on page 3. So if you go to page 3, that starts number 5. So you're also going to be asked to take a derivative implicitly. This is that dy dx stuff. We're going to take a derivative of a function that has both x's and y's, but we're taking the derivative with respect to x. That denominator dx means with respect to x. So we go term by term through the equation, taking the derivative of every part and stating whether it's a derivative of y with respect to x or a derivative of x with respect to x. Okay, so 7y squared, 7 times 2 is 14. So we have 14y to the first. But that is a derivative of y with respect to x. Then we have minus 3 times xy. So I want you to take the derivative of xy using product rule and simply carry on the minus 3 as a constant multiplier. So I'm going to open the parentheses so I can do product rule on xy. X prime y plus y prime x. So x prime is 1, and that's a derivative of x with respect to x. But if you'll remember, we don't write that because that's just also 1. Anything over itself is 1. So we have the derivative of x, which is 1, times y, plus the derivative of y, which is 1, but that's a derivative of y with respect to x, times x. So this product rule is our f prime g plus g prime f. Now that equals the derivative of x to the 4th is 4x cubed plus 0. The derivative of 1 is 0. This is going to be the hardest step. Then the second part of that is solving for dy dx. So we have to get dy dx alone by itself. So we're going to distribute our negative 3 so we can get this dy dx out of the parentheses. So I have 14y dy dx equals negative 3y minus 3x dy dx equaling 4x cubed. Still trying to get this. Why did I make an equal sign? That was weird. So any term with the dy dx is going to stay over here on the left, and I am going to move anything that does not have a dy dx. So I'm going to add that 3y. So I'm left with 14y dy dx minus 3x dy dx equaling 4x cubed plus 3y. I can now factor out dy dx. And when I do that and divide, I have 14y minus 3x in parentheses, 4x cubed plus 3y. And then my last step will be to divide by the factor of 14y minus 3x. So your final answer, which is the derivative of y with respect to x, is that 4x cubed plus 3y over 14y minus 3x. Okay, number 6, you're given this function and you're asked to find the slope of the tangent. And remember, another word for slope is derivative, and another word is rate. but we're going to use the derivative. We want to find the derivative of the function and evaluate it when x is 3. Okay, so my derivative is simple, 12x cubed minus 2. I want to evaluate that f prime, when x is 3. So 12, 3 cubed minus 2. And you get a big number. I guess don't freak out. You actually get a rate, a slope, a derivative of 322. I don't know why the answer line disappeared. All right, then you're asked to write the equation of the tangent line. And remember, anytime you're asked to write the equation, the things you need are a slope and a point. And then we plug them into our point slope form. All right, well, a slope is a derivative. That's what you found in part A. You found the slope. Now, we want to write the equation of that tangent line, meaning the one that we are working with in part A. So we have part of our point. We have the x value, which is 3. And now we have to find the y value. The only equation here, which means y, remember y and f of x are the exact same thing. Y is 3x to the 4th minus 2x, and we're evaluating that when x is 3. So we get another crazy weird number. We get 237. That's my y. So I've got my point and my slope, and we just plug them in. Y minus 237 equals 322, x minus 3, and we're done. We do not have to do anything else with that. And then you're going to be asked on the final to just evaluate a bunch of integral problems. So let's do that. Anti-differentiate. So now we're working backwards. We're adding 1 to the exponent and dividing by the new exponent. And that's how we're going to find big F of x. Also remember, this symbol dx means that the function we have is a derivative with respect to x. And when we go do integration, that's the antiderivative. So we're taking the antiderivative of a derivative. So when I get the new function f, I don't write the integral symbol or the dx symbol. I'm just writing the function that this is the derivative of. Okay, constant multiplier, keep that 4. Add 1 to the exponent, divide by that new exponent. Minus x, add 1 to the exponent, divide by the new exponent, or multiply by its reciprocal. The 4th root of x cubed is actually x to the 3/4. So we're going to add 1 to the exponent, add 4/4. So we end up with x to the 7/4, and then multiply by the reciprocal 4/7. And if there's no limits of integration, if it's an indefinite integral, we have a plus c. Yes, we can simplify this. Yes, that's a 1. But just take the antiderivative and call it a day. Okay, in B, the original function. So I have a constant multiplier of 6 I'm going to keep. This is an e to the u problem. So my antiderivative is e to the 3x. Now u is 3x, but I want to point out a shortcut to you right now. When we have e to the u, after we put in that 3 to get our du, and then we pull out the 1/3, it always works out that with the e to the u, if I was taking the derivative, it would be e to the u times du. If I'm taking the antiderivative, it's going to be e to the u divided by that du, divided by 3. Okay, my minus 7 should be turned, or 7 over x should be turned into negative 7x to the negative 1. Oh, no, it should not. If you do that and you add 1 to the exponent, you get 0. And then you'll be dividing by 0. So most people will do this, and it's okay to do that because we should write our negative exponents as positive, but this is the exception to the rule. When you get this negative 1 and then add 1 to the exponent and get 0, that should remind you that you really have negative 7 times 1 over x, and the integral of 1 over x is ln x. So you have negative 7 ln x. Then we're going to take the antiderivative of sine. I always kind of do this. I make this little note in the corner because I always forget which one's positive and negative when I'm going back and forth. Derivative of sine is cosine. Derivative of cosine is negative sine. Therefore, the integral of negative sine, I have positive sine, is positive cosine. So the integral of positive sine is negative cosine. So I have minus cosine x and then my plus c. Okay, in letter C, there is no derivative that gives me tangent. So we have to rewrite this one as sine over cosine. And then this becomes a u substitution. If u is cosine, du, so if u is cosine, go back to your little handy chart, du is negative sine. So if I plug in the negative and then take out a negative, this is my du. So I have negative the integral of 1 over u du minus the integral of cosecant squared. So I have negative the integral of 1 over u is the ln of u, and we said u was cosine x. And then we have minus the integral of cosecant squared, which means we have a derivative of negative cosecant squared. And if you go look at your derivative cheat sheet, the derivative or the integral of negative cosecant squared is cotan, positive cotan. So we have plus cotan x plus c. And the last one's a little bit interesting. I don't think we did an example exactly like this in class, but it should make sense. It's just a u substitution. But you'll notice something about the du. So let's make our u be 4x squared plus 4. And then our du is 8x dx. Now, if you look at what we have, this is almost du. Instead of 8x dx, we have 24x dx. But 24 has a factor of 8. So let's talk about what we really have. 3 times 8 is 24. So we really have 3 times 8 times x. 24x, 24. X is 3 times 8 times x. And this is my u squared. So when I want to compare this to my du, let's play that matching game we do. I got dx, I got x, and I actually have 8 already. All of this is my du. So I'm integrating this 3, which is still there. I didn't cancel it out. I don't have to put anything in. I don't need to add anything else to my du. So what I have is 3 over u squared, or 3u to the negative 2. Everything else is du. So now I'll add 1 to the exponent. So constant multiplier, keep my 3. I have u to the negative 1 divided by negative 1. So I'm just going to multiply by negative. Plus c. So I have negative 3 u to the negative 1 plus c. Or I could write that as negative 3 over 4x squared plus 4 plus c. Alrighty, that is our next page.